Good afternoon, gentlemen and ladies. It's a wonderful time, and one of the difficult time to present is before the lunch and after the lunch. And I hope that I would be able to keep you all awake and try to share or impart some of the key decisions that as a infrastructure person can think of before putting a data center. This is one thing that you would be countering. Like, in any organization you would see there's a facility team and there's an IT team, and each of them have their own goals to achieve in the organization. But when it comes to put up a data center together, each of them, they have their own criterias, so that there is always a gap. So let us see how the gap can be filled, and how together as IT and a facility team can work together to make sure an efficient data center can be built up. Okay, so top causes, when we look at the data center, what are the causes, or what does what is a key factor for a power loss? So if you look at that, we see circuit breaker overload tripping is about 53.7%, and we see about 16.3% is failure due to UPS or DG sets or any of the other infrastructure equipments. And if you look at other issues such as design or bad design, or maybe rodent cuts or power failures, or basically due to accidental issues, you will see about 30%. So these are the major factors which cause power loss in a data center. So this is a survey done way back in 2015. There was a survey done in about 245 data centers across the globe, and then this is the chart that they could able to come out. What are the factors that contribute to the power failure in a data center? Okay, in a typical design, if you look at there is a source and a B source power has been considered to a data center, and as many of you know, we have two sources and two rack PDUs, and the IT equipments need two power source, for A source and a B source. So this is a typical design, and okay, so let us look at a scenario of a 32 amps circuit on both A and B source, and then you have rack PDUs, and then you have IT servers or IT equipments which are connected, and then we see the power goes to the IT equipments from both A and B source. And how a bad design, though you consider A and B source, how a bad design or not a proper planning contribute to the power failure. If you look at the standard, as per the standards, we should not load more than 75% of the overall load, that includes both A and B source. If you look at there, the source, B is about 12 amps, and if you look at here, it is about A source is about 12 amps. So both put together is 24 amps. So 24 amps of 32 amps rating is almost like about 75% or 80% of it. So entire load, what happens in an event or an eventuality when one source fails? So when one source fails, the load completely transferred to another PDU, rack PDU. So in this scenario, if you look at, the power is being powered by the other PDU. Okay, suddenly you see, some of the servers also loses power, and it goes off, and question would be raised, why? So any thoughts why only some of the servers are getting power and other servers are not being powered? Any thoughts? Any ideas? Why the power failed? Why the power supply stopped powering to the three servers? circuit breaker failed. Why did the circuit breaker fail? Okay, let's see why it failed, what happened and why it failed. Okay. Most of the time what happens is there is a confusion, also there is also information available. Like today we talk about BMS, we talk about data center infrastructure manager or information manager is available. So information is available, but most of the time we don't know what to do with the information. How to arrive, what is a mistake and how to rectify it. By the time we try to identify what is the issues or a challenge, I think there is a lot of pressure for facility manager and also IT manager to fix the issues. So let's see further why it failed. As I explained in the beginning, if you look at the source B, it's 12 amps. If you look at the source A, it's again 12 amps. But look at the detailing of it. The first server is consuming 3 amps and the rest of the 3 servers are consuming 9 amps, right? So similarly, even if you look at the A source, it's a similar concept. So what happens is, in the event of failure, A plus B is actually 100% rating. So what happens is, that is the sub branches. If you look at the PDUs, you have 16 amps and 16 amps, 2 circuit breakers, right? So if you transfer the load on the other side, what happens is, on the A source, if you look at the circuit breaker B, means 1 and 2, the second one is 18 amps. But the rating at the circuit breaker is only 16 amps. So this is actually the, this is a poor design. Or probably when the IT manager is loading the servers and connecting to the power card, they normally do these mistakes. So how do we rectify this? Okay, so most of the time what happens is, when we do a design, the IT person knows what is the load to be calculated for each equipment. There are 2 ways of doing it. One is at the nameplate, the other one is, most of the time what we calculate is the load on the nameplate. Okay, but also some of the time we also calculate, like, what is the ideal power consumed, what is the peak power consumed. Some of us take it a very predictive approach of doing it at the peak power. What is the peak that it can consume? What is the value that it can consume? And some of us design it at 50% power. Because what happens is, when the server is operating at an ideal condition, the power consumed could be probably, for example, if you talk about 500 watts is consumed by a particular server, but at a peak it can go up to 5 times. That's what they say, 500 times, 500%. So the big problem is where people don't realize they have won in the first step. So we don't really think that at the first step itself there is going to be a problem, so we need to really think of it. So a very great professor and statistician, Edward Deming, this is what he coined, telling we don't even think at the first step that there is going to be a problem. Okay, so how do we mitigate the risk? How do we bring this risk down of the power? Okay, so we may think okay, plugging same number of servers to each circuit breaker. Like for example, I had A source and I had B source, so all are 3 amps each, so I can plug 2 servers and 2 servers here and I can balance it. Okay, but virtually it is impossible to predict balance load, because as I said, servers in an ideal condition functions at certain power rating, but at the peak it can go up to 400 to 500%. In that scenario, again, when the A source fails, when the power, the failover drops onto the other source, you see a mismatch in the circuit breaker, because the load balancing is not properly done. So again, there could be a circuit breaker failure, and then you may end up in losing power to the servers. Okay, second thing, some of us may think, okay, let me eliminate the circuit breaker itself, let me use a normal PDU and I can connect it. But that is not the standard. The standard doesn't accept. For example, we are talking about tier 2, tier 3 and tier 4 data centers or TIA standards. So as per the IEC, it is not acceptable. Allocate power by maximum nameplate rating. Again, this is a confusion. You may have a nameplate, on the nameplate you may have a rating of the power, but I will allocate based on that. But again, the actual power use not inconsistent with proportional to the nameplate. Sometimes the power consumed by a particular server is not based on the nameplate. So what is the best approach? The best approach is doing real-time load monitoring. You do a real-time load monitoring with the help of some tools. DCIM is one of the tools that can help you to do a real-time load monitoring, and you can able to connect servers based on that, and you can able to eliminate or minimize the power failures in data centers. We do, most of the time we do reactive approach. Something goes wrong, then we try to act. Some of us do proactive approach. We take buffer and do it, but that really hurts us in the operational cost. And some of us do a predictive, that is a future, with the help of using some tools. So let's see how we can able to do a better future and a predictive way of design. So this is what will end up. When IT and facility guys don't work together, this is where it will end up. Now, the predictive way of management. What's ahead of data center infrastructure management? This is a tool. I think there are a lot of vendors available in the market. So they help you to analyze your data center efficiency in terms of power, in terms of cooling, in terms of servers, also in terms of what kind of software you're using, and whether it's a virtual or it's a physical machine, and where it is located. So everything can be done through DCIM. So what is the most common thing is now, like if you look at in any data center, we do a lather, rinse and repeat process, right? So every year if you want to do an audit of your data center, you try to take the information. Until then, nobody touches anything. No, you don't even know where the server is. You don't even know which port is connected to what. Or even if it is done, at the end of the audit, you will see there will be a lot of moves and changes happening in a data center, right? So information of any assets are manually entered. As of now, you see, we normally use a spreadsheet. We take the information, we key in and keep it with us. But end of the year, if the top level management asks us to do an audit, so we try to go and do it again, there will be a lot of mismatch, because we do a lot of physical things and we don't really keep the track of all the assets. Then what we do, again we do the same process of doing a lather, rinse and repeat process. We again do the same process again. Each time when you want to do audit, we do the same process. And this is an endless loop. There is no end for it. We keep on doing it. It takes a lot of time, it takes a lot of patience, money involved in doing an audit and to keep track of every asset. In specific to IT equipments, I know all your other infrastructure equipments like UPS and DG and other stuffs are quite easy to do it, because those are infrastructure items which is put in one time, and then even if you do any kind of maintenance, it is not like vast number or something that is keep on increasing year on year. But when you look at IT assets, your servers will keep on increasing. Your servers come in and go out. If you take a period of 10 or a span of 10 years, in 10 years, how many times you change your batteries, how many times you change your UPS and your DG? That is something that you put on day one and continues to be there for a longer time. But when you look at the servers, the lifespan of servers, like in 3 to 4 years or maximum 5 years is phased out. You throw it out and bring in a new equipment. According to Moore's law, I understand that Intel doubles the performance, the power of the CPU in every 18 months. That's the concept, for Intel. Every 18 months they keep doubling the performance of any CPU. So having said that, each time when you bring in a server and after 3 years, after 2 years, you phase out, you don't know what came in and what went and how it is connected. And similarly, what model, what serial number, IP addresses, asset tracking, location, where it is located, and how it is powered. Okay, all these informations are very critical. Memories, disk drives, so many things. You keep changing, you keep adding. Today I remember when I started selling the PCs way back in the 80s or early 90s. It was like 286 and 386, and the data, the capacity of the storage was I remember 64 MB and 128 MB. Today we talk about terabytes, and it keeps increasing. So each time you add a drive, you remove a drive, you need to have a proper track of the assets. So in an average, like 15 to 25 different informations are required pertaining to the IT hardware and software in a data center. So how do you keep track of all those things? So again, the cost of rinse, lather, and repeat. This process takes a lot of money. I'm just got the data from my colleague from US. So it costs about $5 per hour to do this process. To know your IT assets, to know your softwares, where it is located. To do this, it takes about the cost is about $5 per hour. And to do for a single device, it takes about 2 hours. Okay, and if you calculate the cost for 500 servers in a data center, just think what would be the cost. Okay, and there could be errors if you do it manually. So DCIM is one such tool which will help you to keep track. There are a lot of DCIM which is available, and we have a specific DCIM which helps you to not only connect your infrastructure, it also helps you to connect your IT assets. So what kind of server, you just connect it and do an auto discovery. It helps you to know what server. Okay, so it helps you to connect your IT assets, your IT servers, what software, what operating system is running on it. And when you do an upgrade, when you add a memory to the server, it automatically discovers how much of memory is added. And it also does virtual machines, transfer of virtual machines. For example, virtual machines keep moving from one server to another server when there is a failover. Okay, so how do you track from which physical device it moved to another physical device? So everything can be tracked by DCIM. All the move adds changes can be tracked, and audits can be done very easily. All you need is when it got upgraded. When did I move from a physical location from one place to another place? Everything is done automatically. So the amount of data that is required for you for an audit purpose, end of the year or any time, if your management asks, is very much available with you in a DCIM. So for over 2 years, the survey done for a data center of 500 servers, which takes about $150,000. And you keep doing it. When you do it manually, you keep doing it. And every year you spend this money. Every 2 years you keep spending this money. Is there any questions before? I've already got a slip that I have got last minute. So any questions pertaining to what we discussed right now? If nothing is there, I think Lars is already ready to talk to you and share the knowledge on the cooling products. Thank you so much.